So this was a question on exam about 3 or 4 years ago. It was on the non-calculator part and it was worth 5 marks. And the reason I bring it up is there were some parts of this which made it a little bit different, and a lot of students got the right answer and only got 2 out of 5. So because of that, sometimes what they've done as a response to this question is they've added the word, before this word, find all possible values of x. Sometimes you'll see the word algebraically added so that you don't just guess and check and figure out what the answer is through that method. Okay? The reason they don't want you to just guess and check because they want you to find all possible values of x. And if you're guessing and checking, you may find a possible value of x, but you don't know for sure if you found them all. So an algebraic method lets you find them all and know that that's the only answer that's possible. So what we have is a box. Again, a picture would be nice. And the side lengths are x, x plus 2, and x plus 10. So our picture helps us get a visual for what's happening here. Write a function v of x. So v of x equals, to represent the volume in terms of x, length times width times height in no particular order, x times x plus 2 times x plus 10. So this is starting to look very much like our other questions we've done so far. But in the last statement here it says, find all possible values of x given that the volume of the box is 96 centimeters cubed. So we know that the volume is 96. X times x plus 2 times x plus 10. So this is the point where many students were like, I don't know what to do next, so I'm going to just guess and check and find a value. It's non-calculator, so they're not going to give me crazy numbers for x. It's got to be a nice value for x, otherwise they'd have to put on a calculator section. So once I plug in, maybe I start with, maybe x is 1. And this would be 1 times 3 times 13, times 11. 1 times 3 times 11 is 33. That doesn't make 96. So what would you probably guess and check next? 2. And 2 is 2 times 4 times 12, which makes 96. And so a lot of students just said x equals 2 centimeters, and we're done, and they moved on. And that only gave 2 out of 5 marks because it's not an algebraic solution. You haven't found all possible values of x. But the problem in this step here is a lot of people said, I don't know what to do next. We have to move the 96 to the other side because you say to yourself, well, how do I solve for x? I solve for x in a lot of these equations by making one side equal to 0. And then you have to use your skills for factoring and so on to do that. Well, that would mean I need to move my 96 over. And even though this is already factored, it's not factored with that 96. So you have to expand everything on the right side. I'll do that first. So if I multiply x times x plus 2, I'll get x plus 2x. And if I multiply that x plus 2x times by x plus 10, I'm going to get, this is x squared, x cubed plus 10x squared, just foiling this out, plus 2x squared plus 20x. And now if I move my 96 over, I get it equal to 0. Now how do you solve for x here? Now we're going to have to factor. So I'm going to let p of x equal this. And this is where, too, as far as a non-calculator question goes, when you're doing your remainder theorem, what are the factors of 96? It's like 1 and 96, 2 and 48, 3 and 32. There's big numbers that you're dealing with, okay? If you decided, I'm going to use my factor theorem and try 96 first, not a good idea, right? Because what's 96 cubed without your calculator? Not very much fun. But you could try 1. And in 1, you would get 1 plus 12 plus 20 minus 96. It doesn't work. Eventually, if you plugged in 2, and we're cheating a little bit because I know that 2 is already the answer. But if I plug in 2, 2 cubed is 8 plus 48 plus 40 minus 96. Sure enough, that's equal to 0. That means that x minus 2 is a factor. And we already knew that 2 was going to be an answer. But how do we factor this completely? Now you would go to your synthetic division, 1, 12, 20, and negative 96. Bring down the 1. And so we get that 0 is equal to, because that was the left-hand side of our equation, we factored out an x minus 2, and we're left with x squared plus 14x plus 48. Can this be factored even more? Or is it done? Sometimes you get one here that you can't factor anymore. But in this case, you could factor this further. Two things that multiply to 48, 8 and 6, and they add to 14, so this does work. So our possible solutions are x equals 2, x equals negative 8, and x equals negative 6. So one of the reasons that x equals 2 wasn't given full marks when you guessed and checked is you didn't show that that was the only solution. But the other thing in this example is because it's a real life problem, we have to think about each of our answers to see if they make sense. You see what's the problem with x equals negative 8 and x equals negative 6? Look back at your picture. According to my picture, x is the height. Can I have a height of negative 6 centimeters or negative 8 centimeters? No. So these ones don't make sense. The only one that makes sense is x equals 2. Again, read your question over again. What were we trying to find? Have we answered everything? No, it says state the dimensions of the box. So our final thing, the dimensions are, and you have to include the units, 2 centimeters by, what was the next one? X plus 2? By 4 centimeters, and then x plus 10 by 12 centimeters. And that's what you would need to get full marks on this. So I'm planning to put one similar to this on your test, okay, where you have to multiply it out and factor. Yes? By putting the x's through these ones, that does state it. And by using an algebraic solution says that that is the only solution.